Hello friends, welcome to Risingpearl.com. We are on series 2 where we are discussing learning triangles. Today is webisode number 12. Friends, today we are going to take a look at special relationship that exists between basic proportionality theorem and we are calling it the other theorem. So what is the other theorem? The other theorem is basically we are referring to this particular theorem. So basic proportionality theorem is also known as Thales theorem. And this is the other theorem we are talking about, which we have seen many times. In a triangle, if a line is drawn parallel, if in a triangle you draw a line parallel to one side, then that line divides the other two sides in the same ratio. Now friends, we have seen what is meant by this theorem, what are the different proofs of this theorem, and we have just concluded a 5-video series where solving questions based on proportionality theorem, this theorem and its converse, right? So we understand what it is. In this webisode, we are going to actually establish what is the relationship between these two. The reason why I wanted to create a new webisode for this, friends, is that in a lot of the textbooks you may see both of them referring to the same theorem. That is, this theorem is also called as basic proportionality theorem. So what we will do in this video is we will start with basic proportionality theorem and we will prove this, and similarly we will subsequently start with this and we will prove the basic proportionality theorem. And as we go through this, you will see there are indeed lot of similarities between them, and why some of the textbooks they actually refer both of them as basic proportionality theorem. So strictly, the famous Greek mathematician Thales, who proposed the universal truth, which is also called Thales theorem or the basic proportionality theorem, it states that in any two equiangular triangles, the ratio of the two corresponding sides are always equal. So let's draw a triangle, and I'm drawing any triangle ABC here, and what we want to do is we need two triangles because we want to have two equiangular triangles. So what I have done here is that I have drawn I have taken a point E on AB and I have taken a point F on AC such that this angle, angle E, is equal to angle B, and angle F is equal to angle C. Actually, this should be only, let's just make it a little bit more complex just to, alright. So angle E is equal to angle B, angle F is equal to angle C. So now we have two triangles here. We have triangle AEF. This is a small triangle, and we have triangle ABC. In these two triangles, we have angle E equal to angle F. Angle E actually is equal to angle B. This is equal to angle B, and angle F, which is this angle, is equal to angle C. Right? Now, an angle A is common. This angle is common to both the triangles, right? So let us just say angle A is the common angle, right? So we can say that by construction, the small triangle and the big triangle are equiangular triangles. So if they are equiangular triangles, we know that the ratio of corresponding sides are always equal. So angle E and angle B are equal. So which is the side corresponding to angle E? It is AF. So we have AF divided by angle B and E are equal. So in triangle ABC, the corresponding side for angle B is AC. AC. So we have AF by AC similarly is equal to AE. AE. Why AE? I am now looking at angle F. So the side opposite to angle F is AE in the small triangle. Angle F and angle C are equal. So in the big triangle, the side opposite to angle C is AB. So this automatically follows. This is the definition of our basic proportionality theorem. Now I want to highlight one thing here. If you look at the line EF and BC, you have line EF and BC such that, and AB is a transversal, so these two angles are equal. That means EF must be parallel to BC. Why? So friends, recall that if you have two lines such that, and if you draw a transversal such that the corresponding angles are equal, if this angle is equal to this angle on the transversal, then we know these two lines are parallel. So if you look at EF and BC, AB is a transversal such that the corresponding angles are equal, so EF must be parallel to BC. So what we have, friends, here is that EF parallel to BC, and also we have this ratio. We will explore, let's explore this ratio a little bit more. So we have just given ourselves some extra space here. So the ratio again is the small side AE, right? AE divided by AB is equal to AF divided by AC. Now if this ratio, these two ratios are equal, then their reciprocal will be also equal. We will just swap the numerator denominator. So we will have AB divided by AE equal to AC divided by AF. Right? I have just simply swapped the numerator denominator, because remember that if you have A by B equal to C by D, then B by A will be equal to D by C. Right? This is just basic fractions. Now the reason I have done this, I have swapped them, is I want to now subtract 1 from both sides of this equation. So what we have on the left hand side here, AE will be your denominator. So we will have AB minus 1 times AE is AE, and on the right hand side you will have AF is your denominator, and you will have AC minus AF. Now if you look closely, friends, what is AB minus AE? AB is this entire length, and if you subtract AE, you are left with BE, the small portion BE. So you have here BE by AE is equal to, similarly, AC minus AF. AC is the whole length, AF is this, so if you subtract, you are left with CF or FC by AF. Now you can just simply again take the reciprocal, so we can write this as AE by BE is equal to AF by FC. Now friends, earlier we have proved, so we started out with taking two equiangular triangles, which was triangle AEF and ABC, the small and the big triangle. So first we found out, if you start with this, first we found out that this side is parallel to this side, and now we have found out that Also, AE by BE, AE by BE is equal to AF by FC. Now, as you can recall, friends, this is nothing but exactly our second theorem. So I hope that, friends, you're able to see why in a lot of the textbooks they consider both of the theorems to be one and the same. So in a lot of the books, textbooks, this theorem that basically, if you have a line that a line which is parallel to one side of a triangle, it divides the other two sides in the same ratio, that is referred to as basic proportionality theorem. And the reason here is why, right? Now let's see if we can start with the theorem and see if we can prove the basic proportionality theorem from there. So friends, here what we have is, we have drawn a line which is EF, and we are starting off with EF parallel to BC. This is given, right? So, and we are also given that AE by BE is equal to AF by FC. This is given to us. So what we are trying to prove, we are trying to prove the basic proportionality theorem from this, right? So the first thing that you will notice is that if you look at the two triangles, the small triangle AEF and ABC, the big triangle, because EF and BC are parallel lines and AB is a transversal, these two angles are equal. Similarly, these two angles are equal. They are corresponding angles. So if you look at triangle AEF and triangle ABC, because EF is parallel to BC, which is given, angle E is equal to angle B, angle F is equal to angle C, corresponding angles, and angle A is common to both the triangles. Both these triangles, angle A is common. So what do we have? That means these two triangles are equiangular triangles. They are equiangular triangles because the corresponding angles are equal. Now also we have this ratio which is given, let's call it 1, because the theorem states that the parallel line cuts the other two sides in this ratio, right? So this is given to us. Now let us see what we can prove with this. Let's give ourselves more space. Now, so we have, let's write it this way. We have AE divided by BE equal to AF divided by FC. So I'm going to take a reciprocal of this on both sides. So what we will get is, we will have BE by AE equal to FC by AF. Right? Now I want to add 1 on both sides of the equation. Since I'm adding the same number on both sides of the equation, my equation will not change. So now let's continue here. So what we have is, if you take the LCM, you will have AE, so you will have BE here, BE plus 1 times AE is AE AE equal to, here LCM is AF, and then you have FC plus 1 times AF is AF. So now let's see what we get. So if you look at BE plus AE, so BE plus AE is nothing but AB. So you have AB divided by AE equal to, on the right side, FC plus AF. FC plus AF is nothing but AC. AC divided by AF. So again, if these two ratios are true, then the reciprocals are true as well. So we will just write it as AE by AB, which is equal to AF by AC. So friends, notice that this is exactly what is the basic proportionality theorem. In this case, we started out with the second theorem, right? This was the other theorem, and we not only proved that these two triangles are equiangular triangles. If we start with this theorem, we just now proved that these two triangles, the small triangle and the big triangle, are equiangular triangles, and also we proved that indeed their ratio of the corresponding sides are equal. So friends, I hope that it helped you see through clearly why in some textbooks they're all referred to as basic proportionality theorem.